All right, guys, I need some electrical engineers with some experience to help me because I'm running into some serious problems trying to make my first RF transmitter. So I have a regular, just a regular crystal one transistor oscillating circuit. Okay. This is connected to the collector. All right. This is basically my antenna. Where this red line is, I got the probe on it right now just to show you what the oscillator is producing. Okay, so here's the frequency spectrum. That's what the oscillator is producing. All right, so I'm gonna unplug the oscillator for a second, the power, so you can see. So that's what it's producing. Okay, now here's the problem. When I take the oscilloscope off of this, and then the jumper wire acts as an antenna, and I can add another jumper wire to it to increase the length to pick up a better signal. So let me just do this real quick. So the oscilloscope is just connected to this open jumper wire, and these two jumper wires put together are connected to the collector. Okay. Collector's connected right there. Okay, so this is acting as the transmitter and the receiver basically. So this is how strong of a signal I can receive. So this is just with a jumper wire connected to the oscilloscope probe. Now that's the AM, FM, whatever radio stations that are near me, okay, in my city, and that's all the signal. Now let me disconnect it. See, that's all being transmitted right there, all that signal. Good idea. That's how strong the signal is that I'm working with. Okay, so that's what I'm picking up on the receiver circuit. Okay, a significant signal, right? Okay, here's the amplification stage. Here's the schematic of exactly what's going on here. Okay, now this yellow wire is connected to the oscilloscope, and I got this connected to ground. Okay, everything past this point is not connected to this at all. So it's everything right here. Okay, this is what the output is of the first stage of amplification. Now, obviously, that's coming from the bias of the second stage, why it has that DC bias, but this is basically it. So that's the signal I'm getting. Okay. Just zoom out a little bit more so you can see. Okay, now I'm going to disconnect the transmitter for a second so you can see what's coming from the transmitter right now. Okay, so that's now when I switch the output to the output of the second stage, here is the non-AC coupled output of the second stage of the Class A amplifier. And here's what happens when I disconnect the antenna. That's it. That's what I'm getting without the transmitter. So that's just there. So let me plug the transmitter back in. That's what I'm getting with the transmitter. And then here is after the 10 nanofarad capacitor. So this is the output of the second stage after the 10 nanofarad capacitor. Okay, so it's a mess, basically. It is a mess. Let me show you the chart. So it's basically a disaster, and I don't know how to clean this up because it's not enough voltage. Now here's with an inductor in parallel going to ground after on the output of the first stage. Okay, so that's what I'm getting. So it's getting rid of some of those lower frequencies And that's a low value inductor. That's about a 10 microhenry inductor. Okay, but it's also squashing my signal, and that is a very low value inductor. So now this is what happens when I take that inductor and I put it on the output, from the output to ground on the second stage. This is on the output of the second stage of the amplification, the second transistor. So that's what I'm getting when I do that. Okay, nowhere near what I need. I need this thing to be like a volt peak to peak and not have all this mess. I've tried adding capacitors to ground with the inductor to make a band pass filter. I've tried band passing at the resonance of the signal when I put the antenna in. I tried filtering between the antenna and the input of the first stage of amplification. I've tried making a bandpass filter. It does absolutely nothing. I mean, this is what happens when I unplug the transmitter. So that's what the transmitter unplugged. Okay? So, I mean, it's just a mess, and I don't really know what to do. I don't know what to do. This is what happens when I just completely unplug ground. Okay, and this is what happens when I take the wire out of that circuit. So now it's just the oscilloscope probe is just floating. And that's what I get. So like I'm really lost. Like that's the transmitter right there. The antenna wire's right here. The antenna wire is literally wrapped up around the transmitter wire. So the incoming signal to this thing from in this green wire is gigantic. So every time I try to, for instance, if I tried it, let's say I plug the antenna here, okay? And then let's say I do a inductor and capacitor to ground to make a bandpass filter, and then I input into the first stage of the amplifier. It does not filter it at all. At all. Whether I put it into the input of the bass, whether after the filter I input it there, or whether I input it directly into the bass, it does nothing either way. No matter how I try to filter that signal before it goes into there, it does nothing. And I think that's because these are high frequencies, right? And they're just connecting anywhere. So if I put a resistor, it's just going to go to this side, and it's just going to go to that side anyway. So the filter's not doing anything. I mean, I don't know what to do.